Welcome, everyone. I think we'll be starting immediately. I don't want us to keep our tutor waiting spant while we expect others to join. I would like to hand the stage over to Mr. Ibuka. Mr. Ibuka, thank you. You have the floor. Thank you so much. Wishing us all a beautiful learning experience. Thank you, everyone.
Hey guys, good day. Glad to be here. Um, I don't know the number of people that I hear today that were here in my first session a couple weeks ago. But yeah, it's always great to be with the Akara team and get to share some knowledge with everybody that joins. Um, right. I believe that we can get started right away, just like you said, success, or is there any other thing that you want to get done before we get right into it? I take that as a no, so we can just go straight into it. Hi, good evening, everyone. My name's Ibuka. I am a software engineer, and apparently I know some things about software and code, and I hope I can share some of that knowledge here today. The focus for what we'll be looking at today is an introduction to Solidity. We've spent the past couple of weeks talking about some blockchain concepts, understanding how they relate to one another, and the underlying ideas about what makes blockchain tick, right? And today we're actually going to get into the actual software part of it, which is how to build software that runs on this distributed blockchain machine. And for starters today, we're going to be exploring the Solidity language. But first of all, I just want to very quickly take a survey of the room to get an understanding of the kind of crowd that we have here so that maybe we can tailor it to better fit people's past experiences because I understand that people learn faster when they can relate what they're learning to some kind of experience that they already have. So just quickly, I don't know if the chat is a good way to do this, but yeah, if you uh, so quick survey. I'd like to know how many people in this room have done any form of programming before: Visual Basic, Scratch, JavaScript, Python, or even SQL. If you've written any piece of code that you've run in an engine before and spit out results before, drop a yes. If you have never done anything like that, just drop a no in chat so I can get an idea of people here. Cool. All right, a couple of yeses. There's okay, cool. I think there's a few more people that have not said anything. I'll say yes because I've done some coding as well, so that's a yes for me. Good. I have a couple no's as well, which is not going to be a problem. We're going to keep this session very easy and introductory. So you can see it as an introduction to both Solidity as a programming language and programming in general. Um, I would I would like for us to like follow along, listen in, and maybe ask questions at any time if we have any questions that I can answer, or if you have questions that you can ask maybe at different junctures during the lecture, and also if it's getting too complex for anybody at any point, maybe it'll be nice to like drop something in chat so I can simplify before moving forward so that we don't lose people here. Okay, cool. The second question I have is. So I'm just gonna put a divider here so I can see. So how many of us here have had any working programming experience with JavaScript or any variation of JavaScript, TypeScript, CoffeeScript, and any of those other variations. You can drop a yes if you've done some JavaScript or a no if you've not done any JavaScript at all. Okay, okay, couple of yeses, couple of nos. Um, okay, cool. Because again, like I would be trying to relate a lot of what we're doing here to some people's experiences. And I think the last time I did a survey of this room, I figured that there were a number of web developers, and that's why I asked the JavaScript question, because a lot of web developers tend to use JavaScript. But okay, cool. We're just gonna dive right into it, and I think first of all, the first question we need to tackle is what is solidity? I'm going to share my screen and just I'm a documentation kind of person. I think documentations are generally the best source of truth when it comes to technical things. And I will share my screen and show a simple Solidity documentation page. 1 second while I share my screen. Cool. Great. Can we see my screen share? Thumbs up? Yes. Okay. Yep. Looks like we can see my screen. Great. Great. So when we go to the soliditylang.org webpage, the definition here says Solidity is an object-oriented language for implementing smart contracts. That's probably like the shortest one-liner definition of any programming language I've ever seen. And smart contracts are programs which govern the behavior of accounts within the Ethereum state. I was mostly not around last week, and but I saw that we covered a bit of understanding of what smart contracts are and what they can be. But again, just to touch on that a little bit, smart contracts are essentially pieces of code that we run on blockchain networks, on fully decentralized blockchain networks, that anybody can write a piece of code, push it to the blockchain network, and have the blockchain network execute that piece of code for a fee, right? The reason why they are called smart and the reason why they are called contracts is that one, when you push code to a blockchain network, right, and you execute it, it'll always do what the code has defined that it should do, right? So if we write a piece of code that says, if Spain wins the World Cup in Qatar, I want to transfer one Ethereum from my account to your account. Now, if we push that contract to the blockchain network and sign it, at the end of the day, if some source of truth comes at the end of the World Cup and says Spain has won the World Cup, and we execute that smart contract, one Ethereum will move from my account to your account without anybody intervening in that process. Right? That's essentially what smart contracts are. And Solidity is the language that we use to build these smart contracts. They just won their first match. Let's just see. We still have many more games to go, so we'll see. Cool. And yet, if they don't win, probably the one Ether will be returned to my own account. Essentially, that's why they are contracts, right? They are binding by code, and Solidity is one of those languages that is used to write these smart contract code that are run on the Ethereum virtual machine. Yeah, that's essentially what it is. There's a lot more breakdown of all the things, the technical details of what Solidity can be as a language, but I think when it comes to code, the best thing you can do for yourself when it comes to code is to dive into the code and try to figure out what is happening in the code and make sense out of it and eventually start building stuff. I would even dare say that probably like 90% of people that build Solidity smart contracts know probably less than maybe 70% of the language as a whole. but they can build like really powerful protocols and build really powerful smart contracts that run day to day, move like a lot of money, and to be able to get things done, right? So we are going to just dive right into some code very shortly. Before we do that, does anybody have any questions before we move ahead? Okay, no questions. So we're gonna go right into some code. I would like to share a link for some of us. We're going to use a web IDE. So essentially, web IDE is a web page that provides us with a code editor, a smart contract compiler, and a smart contract deployer that will give us all the tools that we need to deploy like functioning smart contracts in a test environment and play around with them and get a good understanding about how these things work. For the more experienced folks that have some understanding that would like to follow along and play around with some of the things that I'm doing as well, you're welcome to do that. For the people that are here to just understanding and would like to maybe watch a recording of this, eventually to maybe try their hand on some of the things that we're doing, you're also welcome to do that. But we're going to be using the Remix IDE for some of the work that we're going to be doing here. Remix IDE is a fully functional web hosted integrated development environment. I think that's what they're called. Yeah, integrated development environment that we're going to be using to write some cool Solidity code. I will be sharing my screen, so if I miss any messages, because I'll be on the other tab, maybe Success, you can just draw my attention to it, and I can just get to it right quick. Or maybe like anybody that has a question can just unmute and let me know if they need to pause me for a second to do something. Right? Cool. Great. I'm going to share my screen. Good. This is my instance of a Remix IDE. So just very quickly, just introduce you to what you're seeing here. This is an IDE where you write code. For some of us that have done some software in the past, this is akin to your Visual Studio Code or Visual Studio or PHP Storm or Atom or whatever it is your preference. It's basically a text editor for you to write code and see the different parts of the code tokenized and colorized for easy development. There's a file explorer here to the left that shows you the files that you have in your workspace. You can see we have a contracts folder, scripts folder, tests, etc. And then we have some tabs on the left here. The one we have open is a file explorer. There's a file search. Any decent IDE should have file search for you have huge files. There's a compiler tab. We're going to get to this shortly. And there is a deploy tab that enables us to deploy our smart contracts after we've written them. Right? So very quickly, I am going to create a file here. I already created a file here in this workspace. There's a different workspace, but I think we can work with this one for the sake of time. We're going to create a file here called hello world.sol. So the extension on this file name is .sol. That tells us that it's a Solidity file. Just like when we have our .js files that mean .javascript or .py that mean Python files, the extension for the Solidity language is .sol. And we're going to just, get into it and start writing some code. I'm going to delete all of this code, and we're just going to start with a fresh file. Good. When we're looking at a Solidity file, usually you see many smart contracts start with a line like this, where we have a license identifier. This doesn't necessarily mean anything. It's not necessary to have that, but for good licensing and coding patterns, you just define the license for the smart contract that you're writing. Again, we're in the contracts folder, and we created a file called hello world.sol. A common line you see at the start of a Solidity program would be the pragma that defines the version of Solidity we want the smart contract to run on, right? What this looks like essentially. Quick one, is my screen share big enough? Can we see it very clearly, or do I need to zoom in a little bit? Fine. Okay. Looks like it is fine. Cool. All right, we can go ahead. Okay, zoom in a bit more. Okay, I'll do that. This is my first time using a Windows laptop in a long time, and it is interesting to say the least. I will. Okay, this looks a bit zoomed in, and I will just turn this down a little bit. Cool. Good. Back to IDE. Great. So the first line in our Solidity code that is actual code is the pragma, right? The pragma statement. Essentially, the pragma statement indicates the Solidity version that we're using to run the smart contract, right? So what this does is say for anybody running a smart contract VM and Ethereum virtual machine, this is the version of Solidity that this code is compatible with, because just like most other languages, Solidity also evolves and new versions are created all the time, right? The language is actively growing. You can see it's actually a language that is still in version 0 point something, so it's actually still in active development. But this tells us the version that this could work on, and for this specific one, we can see that it is specifically defined as Solidity, any version that is greater than or equal to 0.7 and less than 0.9. So Solidity version 0.7 would work with this code correctly, 0.8.5, 0.8.7, 0.9, and anything less than 0.9. So which means if you try to compile this or run it in an environment of 0.9, it's not going to work. As at last check, I think the current version of Solidity is at 0.8.17, so we should be fine with this. Also, while I'm doing this, I'm just going to share a link to the Solidity docs for the curious ones that want to take a look at some other things while we do the rest of the code. Cool. We are done with the pragma, and we have defined the version of our code for Solidity. And then this now brings us to the meat of what we usually do when we write smart contracts, which is defining the contract, right? This is a contract keyword. And I'm going to create a contract here called hello world, right? Now, for any smart contract file, this is where all your code lives inside, because this is akin to writing a Python or PHP or JavaScript class, right? I'd like us to visualize it like that for people that have done some software in the past. This is akin to doing something like class animal in JavaScript, right? And then defining methods, functions, variables, and types inside of that class, right? And in Solidity, we define it as a contract, because essentially whenever you deploy this contract, it's the code and the methods inside of this contract that become available for anybody to execute on the public blockchain, right? And a standard pattern here is also to name the contract, give the contract the same name as the file name, right? So here we have a hello world.sol file name, and we create a contract called hello world. This is a general standard when writing Solidity files. Now, what can smart contracts do? Smart contracts can do a bunch of things, but at the base of it, Solidity is still a Turing complete programming language. So what that means is that we can use it to do simple programming tasks that can achieve simple things. I'm talking arithmetic, multiplication, addition, string manipulation, and up to like more complex things like moving money between accounts, building decentralized exchanges, building decentralized marketplaces, marketplaces, and the like. So you can go from a simple smart contract that has 10 lines of code that does something very simple to having like a collection of 50 smart contracts working together to as what's the most popular one these days? I don't know what are we trading these days, chat? Uh, I haven't done some crypto trading in a while. I think I'm getting rusty. Any of the 1,000,001 crypto tokens and coins that even the widely used ones like USDT, essentially at the base of them, what they are smart contracts. It is basically code that is running on a blockchain that defines that somebody can send 20 USDT from his own address to somebody else's address. It's also the same thing that, say, for example, NFT marketplaces like OpenSea are built on top of. Let's say somebody can list an NFT and somebody can buy that NFT and somebody can receive the money for that NFT. All of this are built with smart contracts. Cool. So we're going to just, see how some of that stuff is done. But first, the simple part. Programming involves a lot of data, right? Variables, data types. How do we create them? How do we manipulate them? How do we move them around? How we're going to be them now. Cool. So we have created a contract called Hello World. What do we want this contract to do? We want this contract to return a string that says Hello World, right? And for that, I am going to create a variable that has a type of a string, right? And call it hello. Okay. Essentially, what I'm doing here is creating a state variable for this contract, right? That the name is hello, right? And I'm eventually going to assign a value to this string type, right? I can assign value to this in a host of different ways, right? Either doing my contract initialization or have somebody call a function to change the value of that string, right? Matter of fact, I'm going to call this string message is an ambiguous word. I'll just call it output, right? And then have somebody set what this value is, right? This is a data type of string. I can have data type of uint. This means an unsigned integer. An unsigned integer is used to store numbers, essentially. There's multiple kinds of unsigned integers that define the size of the integer. There's the uint 8, uint 16. It just basically defines the width of that data type, uint 256. Or we define uint, it just means we want to store numerical values with this thing. And I'm going to set this to the count. And I'm going to start writing functions that we can start calling in this smart contract. Cool. 1 second. While I move over here. And cool. Address, Solidity. Switching between a couple tabs, so just give me a second. Cool. So now we're going to write functions. What do functions do? Essentially, functions are actions in our code that we can call to make things happen, right? So if we look at variables like this as nouns that say a message is a string, right? With the name of message that is a string, functions are the things that can operate on those nouns, which are like verbs essentially. So like functions are verbs. A function can be something like run the verb that does something. A function can be update something, and essentially anything that a function can be transferred. So say transfer money is a verb, right? That says transfer money from person A to person B. These are what functions are. How do we write functions in Solidity? Writing functions in Solidity essentially starts with the keyword function. We write, I'm going to write out a simple function here that says function set message, for example, right? And set hey guys, can you hear me? I got disconnected for a second. I think my Wi-Fi restarted. Thumbs up if you can hear me. If I'm like, great, thank you, Adam. Cool. We're going to go back to writing our simple function that does something. I think I'll share my screen one more time. Okay, where's the share screen button? Right here. I will share my Remix IDE tab. I think I'm sharing now. Great, presenting your screen. So I'm going to write a function here that can allow anybody from the outside world to set the value of this message, right? And I'm going to make it public. The reason I want to make this is a scope. Again, like I said, the reason I want to make this public is because I want anybody from the outside world to be able to call this function. Now, just a very quick recap of what some of these smart contracts are. Essentially, this is code that is living on the blockchain that anybody with access to the blockchain can call, right? So when I say can call, it means I have a wallet or I have an Ethereum node, for example. I can literally execute any code running on the blockchain and pay for that execution. So it's like a decentralized computer that has billions of lines of code in different smart contracts, and I can find a specific smart contract and call functions on that smart contract to make things happen, right? So I'm going to
Hi everyone. I can't hear Mr. Ibuka, but let's just give him a few minutes to reconnect. His network is probably acting up again, so please just hold on for a few minutes. Let's be patient while we wait for him to connect back. Hi, Oluwaseun. I'm here. I actually didn't want to break the communication by playing music, but since you're requesting, let me keep us company while he connects with the
Hey guys,
Ibuka.
yeah, my router cut me off again at the worst possible time, but caught off during that. But yeah, sorry about that. Essentially, I was saying we're gonna go to like the very important part of smart contract development, which is compiling our smart contracts, deploying them, and then interacting with them, and then yeah, doing that part. But before that, does anybody have any questions around like the very simple code that we've written so far? Oh, oh. Okay, good seeing you, hand again, Ray.
Hello. I hope. Can you hear me?
Yes, I can hear you.
Yeah. Okay. All right. Yeah. I was just wondering when you look at other programming languages such as Java, we have the access modifier in the first place before you define the name of the function or the method.
Mm-hmm.
So for Solidity, I have seen that you start with the naming that this is a function and its name. Then after that, we specify the access modifier. For instance, here you indicated public, or else it will be private and so on. I don't know. Is it a rule uh, in Solidity or maybe something else?
If I get your question correctly, are you asking about the placement of the access modifier?
Yes, exactly. Yeah, that's it.
Yeah, so Solidity's standard is uh, basically to have the function keyword, the function name, the parentheses opening, the parameter list, the scope or the access modifier, the returns keyword, and then the body of the function. That is how it's generally defined in Solidity. Yeah, I think they adapt more to C style languages. A bit more. Java is quite different, but essentially they do pretty much the same thing. So what we call scope here that you're able to infer is an access modifier. Those the standard for Solidity is to have it in this pattern where we define all of these things one after the other.
Oh,
Is
thank
that
you. Yeah, yeah. Thank you so much. Yeah, got it.
cool? Does anybody have any other questions? Yes, absolutely. You can write Solidity using any editor that you want. Um, yeah, you can definitely. There's a lot of extensions that make it easy for you to write Solidity inside of VS Code without any problems. Yeah, the reason I'm using Remix IDE is because there's a lot more to just writing the code I would like to do, like compiling and deploying, which can be very tricky if you have to set up your whole environment by yourself. And that is why Ethereum has this Remix IDE for us to play around with things and make our lives easy. Any questions? All right, cool. I'm going to share my screen once more and we will continue from where we stopped. Share the tab. Back to our code. Great. Just a quick recap before I dropped off. A couple more keywords that I added here. Memory for string, memory is string. You don't have to worry about why we did this just now, but Solidity has a couple quirks about how it stores data and where it fetches data from, whether it's called data or memory, but we're going to get into that when we talk about some more advanced concepts in Solidity. Now I have saved this file, and I'm going to go over to the compiler tab, which is this one that has the Solidity logo. over here, and I'm going to select a compiler to compile this code. I'm going to select the 0.8.7 compiler, which, as we can see from our pragma definition, would work with this file because we have defined that any compiler between 0.7 and less than 0.9 would work. So I've selected that. I'm going to choose the file that I want to compile here, which is my hello world.sol, and I am going to compile it. Essentially, what this compiling does, just like in other languages, is to take a high level language like this and compile it to more low level code that can be deployed to the blockchain. Good. So now that I have compiled this, I'm going to go to my deploy tab. Now, this deploy tab, just to explain what is happening here. Now, mind you, for us to run any smart contracts don't run in isolation. They have to run in a blockchain, right? So to test this code, my options are to get this code and deploy it to some form of blockchain. Maybe you want to have, like I said, you can create any kind of peer-to-peer network with you and your friends. Like you can spin up 3 computers and set up a blockchain with 3 nodes if you wanted to. But when we're writing code like this, we would like to be able to set up a virtual machine or a simple blockchain, and Remix IDE helps us do that, right? So we're selecting the VM we want to run this in. The guys over at Remix have done some pretty nifty work to create some VMs for us in different locations to deploy our code in. I'm going to select the Remix VM in London for this. Also, they've helped to give us a number of different accounts to work with. So again, just to touch base on something that I must have touched on last week, is that for any interaction you do with the Ethereum network or the Ethereum virtual machine, it has to be through an account, right? And these accounts are technically like our wallets. For example, when you want to transfer a token or accounts that you're using to do it. And also, when you want to deploy code to the action that you need to do. So every function call on the network is essentially a transaction, right? And that transaction is just the execution of code, right? And it will also cost ether because essentially what you're doing when you're deploying code is packaging up your code after compiling and essentially that network to run that code is from. Filled it up with load. Now I can deploy, say, like how much, so I don't have to worry too much about how much gas I want to do. I'm just going to deploy this. So when I click deploy, essentially what I'm doing here is that I'm pushing this code to this Remix VM that has been hosted somewhere, right? It's a test blockchain, a self-contained blockchain that I can deploy my code to, so I can interact with it. Now, after clicking deploy here, I can see a message here, just very simple message here that says, this looks a bit small, but I hope it's good enough. Just going back here. If you can look over here in my debug console, it essentially says so this is an execution from the VM, a message that came back from the VM. It says from this 0x5b something, which is my address, my account, right? I sent this transaction, right? Data, whatever is in this data is my compile code that I pushed to the Ethereum virtual machine. And the status is true, which means it was successful. Transaction mined and execution succeed. So it's telling me that the deployment transaction that I just executed happened successfully. And some of that information here, it says it cost me 356341 gas. Again, for every function execution deployment you do on a blockchain, on a distributed computer, you have to pay for it in form of gas, right, which costs ether, right? And then all the other information around what happened with this deployment. That is what is happening here. If you look at my account here now, I have gone from having 100 ETH to having 99.99 something ETH. So this cost me money to deploy. So now that I have deployed this contract onto the blockchain, right, I have access to it here. Now I scrolled all the way down. There's a section here called deployed contract. So essentially, deployed contract giving me access to this contract that I have deployed. One more thing as well you need to see is that when I deploy a contract, that contract now lives at an address, right? If you look here, this 0xD91 that ends with 138 is the address of this my contract in the global Ethereum virtual machine. So it means that if I want to call contracts, if I want to call functions on this contract, I need to use this address as the location of that contract and then execute the functions on that contract. Good. Now looking here, we can now see two things appear here. One is set message. The other is get message. I guess you can correlate that these two things are the two functions that I defined in my contract, two public functions that I defined in my contract. Essentially, what are these things? These things are giving me public access to the contract running on this address, and now I can execute code on them, right? Set message is interesting here because it allows me pass a value to this function. So this value that I will define here, string, new message, right? That will set the value of the string that we created here. So here I'm going to send a string value called hello, and I'm going to call set message. Right? When I call that function, the screen is pretty small, so I have to open up the debug console here. I'm just going to open this last. So for every time I call a function, I execute a transaction. So something like this will happen every time I call a function. So you can see here, same thing happened for transaction mined and execution succeeded. And here it says from my address, which is this one that ends in C4, right? From my address, I called hello world.setMessage and I passed a string, and it was successful, and it cost me 45021 gas. That also costs money to execute that transaction. So what that means is that the next time I call the get message function, I'm going to get the value hello. If I go and change the value of that thing again to hello world, and I execute a transaction. Mind every time I call set message, because it's a function that changes the state of the blockchain, it costs me gas. So if you look at these nines, there's millions of nines here. You can see them going down for every time I call set message, and there'll always be this transaction verification happening here, right? If I then go and call get message, I will get a new value called hello world. Now, this is programming in its simplest terms, right? All of what I did here can be done in any simple CLI language, scripting language, run locally, executed. It's simple, like input, output. This is an input function that sets the value, and this is an output function that returns what that value is in state, right? And this is a very simple concept. Now, why, like, what do we do with this? Like, how is this thing valuable to us, right? Those of us that have written hardcore programming and software in our time wonder, like, how is this valuable? How is this? The thing with decentralized networks now is that all of this code that I ran here today was not executed on my laptop, right? It was executed in a globally distributed blockchain in a virtual machine, right? So for every time, and that is why I have to pay some kind of money or give some kind of value for that execution, right? Because and that's why you have to pay gas when you want to send cryptocurrencies from one account to the other. Because essentially, the execution of that code is not happening on your local machine. It's not happening on your mobile device, right? In fact, the code itself doesn't even live on your mobile device. This code that we wrote here, we just use this IDE to write this code, but we had to compile and deploy that code. This part that we did here, deploy. Now, what is happening when we deploy this code? we're packaging this code and we're distributing it to all the network nodes that are running the Ethereum virtual machine across the world. Like there could be like a million of these machines, right? Now, once I've deployed this code, multiple things are true here. The first thing is this code can never be changed, right? If somebody comes to read this code and say somebody deployed this code 6 years ago, and this is what the code does, and this is where that contract lives. Like I said, the contract has an address. In our case, this is our smart contract address. This one right here. It's longer than this. Anybody can just locate the address of that smart contract and call all the public functions on that contract, and it will do exactly what the code was written to do. This is what makes smart contract programming very powerful, right? Because what that now means is that because nobody can tamper with the network, even simple function calls like this can be used to build very solid abstractions around things like, for example, money, right? Because we have a distributed ledger system, right? What it will take to move money from one account to the other would not involve any complex algorithm that has to do checks and balances and make sure that, like, maybe like if you're building a bank today, for example, your ledger system alone will probably have maybe like 2 million lines of code, just your ledger system that balances the books and that makes sure that there's money in people's accounts to transfer. But on a decentralized blockchain like this, because and also code that even verifies that code should do what it do. But literally, as we'll see very shortly, when I just do a bit more fleshing out for this Hello World and so on, we could build a pretty, working, consistent balancing ledger system by doing simple arithmetic on accounts, right? So even though at the core concept, Solidity is a very simple language that does very simple things, because we have code running on a globally distributed network, right? We can build like more powerful systems with them because the code will always be true. So for every time I deploy this code, it will always do what we have defined that it should do, right? Good to set message, and we get this message. Very simple ideas and concepts. I want to okay, first before I go forward. Does anybody have any questions in chat? Sorry, I've not been looking at chat. I just came back. Somebody says, please share link for the IDE. I shared that earlier. I will share it again. It's remix.ethereum.org. You can play around with it. You can, so for any time you see like a Solidity tutorial or anything, you can come here and write all the code you're seeing and deploy and test, without having to worry too much about setting up your own blockchain on your laptop. Those things can get a bit complex, but I think Remix makes it easy to at least get started and then get a solid understanding before we start doing some of those more complex things. Somebody said, I noticed that you use uint to define unsigned integers. Is this equivalent to uint 256? The answer is yes. Uint in Solidity is a shorthand for uint 256. So essentially, this would take the largest with unsigned integers available in Solidity, which is actually the maximum safe integer that is available in the language. Yeah, does anybody have any other question? What about memory key? Good. I mentioned that the way Solidity handles data can be a bit more complex than in other languages because of some constraints, and it can become a rabbit hole very quickly. But essentially, when we're dealing with some kinds of data types like bytes and string, right, we want to explicitly tell Solidity where that value should be kept during execution, right? So essentially here, like when somebody passes the string new message to this function, right? Solidity is going to hold on to the value of this new message in memory until this function has finished executing, right? And then return. And in this case, we didn't do any returns. It's a simple function that just updates state. and then execute it. There are also other values like call data that mean something slightly different and can actually affect the amount of gas that you pay per transaction. Those are a bit more advanced concepts around Solidity that we will deal with in eventual topics as well. Any other question? Okay, none. All right. Cool. I'm gonna spend some more time just going into variables a bit deeper, so we understand like the kinds of data and variables that we can handle in Solidity. That will like basically round out a good enough understanding about what kinds of data we can work with in Solidity, and yeah, maybe that would give us a pretty good understanding. Cool. Just 1 second. While I get to the data types. Cool. Good. So in our hello world example, we have defined a simple string data type and an unsigned integer data type, uint. There are also a couple more data types that are pretty common in Solidity that I'm going to explore a little bit here and how we generally use them. And some of the most important ones that we use in Solidity are a data type called the address data type, right? I'm going to create a value here called admin, right? For example, I'm going to create a data variable here called admin, and I'm going to create a mapping data type, right? That essentially defines, once again, for some reason I can't type while I talk at the same time. That's weird. But yeah, I'm just going to call this first. Actually, what is an address? An address is a data type that is used to hold address keys, right? Address is a special data type in, because we do a lot of address related things in decentralized computing. Who sends the transaction? Where is the transaction going? Where is the smart contract hosted? There's a lot of addresses. We have a data type called address. This basically holds values like these. Like when I open my accounts, for example, each account in this place has an address. These are a bit longer. They are like characters most of the time, but they're like when somebody sends you their Ethereum address or their USDT address, pretty long address or their S type in Solidity. You don't store them as strings or as bytes. You store them with a special type. Essentially, a Python developers probably of key value pairs. Some other languages will just simply call them maps, but essentially a mapping data type essentially says this is an object of key value pairs where I define the type of the key on the left, right? And you have this characters here, and then the type of the values that we're going to have on the right? This will look something like in JavaScript, for example, this will look something like you have an address here, you have address string, right? And you have 20, right? These are the kinds of values that you can store in a mapping, right? Do something like this as well. It is like this is a simple visualization of what this data type is saying, right? Oops, I missed something here, actually. Sorry, my bad. That is not where this ends. So this is the, oops, my tabs are going crazy. This is the definition of the types, and then you're going to define, to give it like a name, right? I'm going to call this balances. So type, this is the type here, everything here basically says this is a mapping of addresses to integer values, and the name of the variable is balances, right? This is a type of address of admin. It looks for a bit over time. I'm just gonna be very quick and just show these two data types. They are they're very powerful data types that are used across smart contracts. I just want to touch on them a bit before we close for the day. And how are these used? I'm going to do some simple examples for how these are used. And we're going to in the same contract, just write some methods or functions to credit people's accounts and debit people's accounts with these data types that we've created here, right? So I'm going to write a function here called credit account the amount, right? That defines the amount we want to credit their account. We want to make this public. I'm going to close this very quickly. We're going to make this public, and yeah, that's pretty much it. And I'm going to say for every time I call credit, right, I want to update balances of the receiver and add amount to that receiver's wallet. This is a simple credit operation. It's like saying balances dot receiver plus equals amount. Now something simple here. The receiver is of an address type. Amount is a UNT type. And then we can see in this mapping that we defined here, which is balances. Inside of balances, we can say this receiver as an address, in this case, should have this amount in their wallet, right? We want to credit their wallet. That's essentially what we're doing in this one-liner, right? And then we want to, we've done this, right? This becomes a public, and then I'm going to define a function called advance. And what it's going to do is going to take the address of somebody account. Right? This is going to be a view method because we're just going to be reading data from state. We're not going to be changing anything in the blockchain. And it's going to return. We're going to return here a UNT, I believe. When we're using UNT values, no, we do not necessarily need to define the data type. A UNT is a simple data type that is automatically handled. And here, this is going to return a UNT value because I want to get the balance in somebody's account. Here, I'm just going to use a return keyword, balances, and then index on the account. Essentially, this will reach into the balances dictionary or the balances object, right, and access the value on account. All right. So, very quickly, can somebody can you maybe voice out your questions or maybe success? You can help me point me when people drop messages because I'm on a different tab and I cannot see when messages come in actually. So the question is, with Solidity, do we have to keep compiling every time it's changed to meet our code? Yes. So just a solid concept to understand here. Now you see how we're writing code and recompiling and redeploying. In real life smart contracts, like smart contracts are, I call them weird because they're not like your JavaScript code that you can write and chain and redeploy every time. The thing with smart contracts is that once you have deployed the smart contract, essentially that smart contract cannot change till the end of time, right? So actually, when I save and compile my code and deploy, I'm actually deploying a new smart contract. All right, and I'll show that here very shortly. So which means if I write a smart contract now that does something and I deploy it, that code has gone live forever. Like if there's any money that I locked in that code until something happens, I cannot come back tomorrow and update some of my code and then deploy and change that code. And that's why they're called contracts. They are eternally binding, right? The reason we're doing this in our local environment is that like we can deploy a new contract, discard the old one, and just act like it never existed. And that is one thing that makes smart contracts all the more, I wouldn't say difficult, but that's something that separates like smart contract development from, say, web development or app development and the likes. Because there are no updates, like the technical level. Essentially, at the core of it, when you write smart contract code and a major challenge back tomorrow fix bugs. Once you deploy the smart contract ever without change, it is very weird, but it's that's actually what makes smart contracts very powerful, right? It makes them very very powerful because now it's a completely different mindset, right? This is why like there's a whole lot of testing that goes into smart contracts, especially the ones that handle money. Because when you hear, for example, that a protocol has been hacked, for example, when you hack a bank, for example, a bank can be shut down, the databases, turn off their networks, deploy some new code, change some things, fix some bugs, redeploy, and they're fine, right? When you hear that a smart contract, what people can do is literally to just look and just this just gives a whole new dimension to development of smart contracts, and it's a whole different frame of mind generally with smart contracts. I'm sorry, Shange, can you voice your question? I'm not sure I get what you typed in chat.
Can you hear
Yes,
me?
I can hear you very loud.
Sorry. Okay. Oh, okay. Thank you. So I'm asking. So the use case of this is you can, for example, create a smart contract to specify when somebody can get money from your account.
Yeah, essentially anything code can be you can define a smart contract to do it. So you can define, for example, you can say you can implement something called locking. For example, you can say nobody can withdraw from the smart contract until the 15th of December 2022, right? And you're going to write that in code. You're just going to say if the time is less than 15th of December 2022, throw an error. If anybody, and once you deploy that smart contract, anybody that calls that function before that date would not be able to execute that function successfully, right? That's why it's a smart contract, and it will not change. Like it will absolutely not change until that day. And once that time passes and somebody calls that function with the right parameters, the thing that the function has been written to do will be executed, and everybody will be settled. Cool.
Okay. Yes. That was clear. So then, if you make a mistake, you can make another smart contract to reverse the first one. Say,
you don't.
can you make some other?
No, you don't erase the first one. You just create a whole new smart contract. Now, but what that means is that if there's any value that you've locked in that original smart contract, right? Let's say you placed a bet and you wrote it in a smart contract, right? And then because they're smart contracts and they do what code defines that they do, people can actually put money in a smart contract and let the smart contract release the money only when some things have happened, right? Now imagine a world where you write a smart contract and you lock your money on that smart contract and then realize there's a bug. If you write a new smart contract, it's not going to have that money and it's not going to replace the existing smart contract. You're just going to be writing a new smart contract. And that's why like there's actually a lot of times that some money becomes locked forever in smart contracts because of bad code. And there's probably like billions of dollars that are locked in smart contracts forever that are never going to come out because somebody wrote less than instead of writing less than or equals. And that's a smart contract that would never release money to anybody. Yeah, it's pretty interesting stuff. It's not like regular software development that you can just iterate all the time. But there are ways, there are patterns, but just in that smart contracts at the core of them live forever and cannot be changed. Right?
Okay.
Cool.
Thank you.
I'm going to very quickly deploy the updates I have made to this contract. I compiled this code again. I'm going to deploy, and also just to kind of prove that, I'm going to just, sorry. I'm going to deploy a new contract. Contract has been deployed. You can see this is deployed at 8CB47. This is a whole new contract from the old one that we had, right? And if you look at this contract, the public functions that I have are now available to be called from the outside world to do things, right? Cool. I'm going to do a bunch of magic here. I'm going to bunch of addresses here. So I'm going to select the second address. I'm going to cop credit that guy 500 of something, whatever that thing is, right? I just called it. It was successful, I believe. Yep. Oops, that is wrong. I think there's an error here. Error encoding arguments invalid. What? Something's wrong. No, that's constructor. My screen is so zoomed out I can't even see this error properly, which is weird. Oh, okay. I need to pass the amount and the receiver. Sorry, I didn't put the receiver. The receiver is right here. Credits. Hope this was successful. Okay, I can scroll here actually. Is it the address first or the amount first? Ooh, this is tough. Okay, the receiver first and then the amount. If you call wrong parameters, of course it's not. I'm just going to credit this guy 500. Be this guy's account and call get balance on this guy's account. I'm going to get 500. I credit him an extra 200, say. I call this and I call credit once more. Balance. Good. So this is done like this. Now, if you're using this for a real accounting system, obviously this is terrible because essentially anybody can just call a function and add money to somebody's wallet, and that's not how things work, right? So we're going to do something that maybe something nifty that says maybe only the admin can credit people's wallets, right? Only admin can, and also just to show something here, if I copy any of these other and I get balance on this guy, I get 0. This guy has never been credited, and credit somebody's account. How do we go about doing something like that? I created a variable here called admin one time that is of an address type. In smart contracts, there's something called an owner of a contract, and owner of the contract generally refers to the person that deploys a contract, right? So if I create a contract and I deploy it, there's a pattern that I can use to assign my deployment address as the owner of this contract to do privileged actions that only allow the owner or the admin of that contract to do them. I can do an if check or something of that nature to say the person executing this function, are they the admin? If they are not the admin, you're just not going to work, right? So we're going to use something called a required keyword to implement this very shortly. Now, how do I define that how do I make the deployer of the contract the admin or the owner of this contract? We're going to go into the constructor keyword. For those of us that have done some programming, constructor keyword is essentially what is called when we create an instance of a class, right? And remember when I started this, I was mentioning that essentially a contract is essentially a class in most languages, right? A deployment of a contract is creating an instance of that class and deploying that object instance into the cloud blockchain, right? Into the EVM, right? So what that follows to say is that whenever I click deploy on this compiled contract, essentially I'm calling the constructor function, right? I'm calling the constructor function. So the transaction happening in this constructor is what happens when I deploy this contract, right? And what do I want to do this constructor contract? I want to essentially say my admin is equal to message.sender. Now, message here, this MSG is a global object that's available in Solidity that has information about the current transaction. And when I say that current transaction, the person that's calling this function, how much gas is being spent on this transaction, what's the data being sent in this channel. It has a bunch of nifty values in them, and one of them is the sender. The sender basically gives and this is an address value, so that's why I can assign this message to sender to an address type, right? Because message to sender has an address. Now, when I'm deploying a contract, the person that is deploying that contract is the message sender, right? If I want to access that value, it's inside of message.sender, right? Good. So just by doing this admin value will have one value and one value only for the lifetime of this contract. It can never change. Because you can see here, this is where I'm assigning the admin. All right. So which means if something happens to the admin, maybe they lose their keys or their wallet, nobody can credit anybody again. Again, smart contracts, pretty weird stuff. So you have to probably be building things into place that maybe can allow the admin to transfer ownership to somebody else. But that's a conversation for another day. So now that we have an admin, how do we make sure that only an admin can do credit transactions? And we do that by using a required keyword. A required keyword essentially equates to using like an assert keyword in most languages. I think there's assert in JavaScript, assert in Java, in C++, in so many languages that says if only continue the execution of this program if this assertion holds true, right? So it usually goes something like assert Boolean execution error, right? So if this Boolean check here fails, throw an error and do not continue execution. That is what the required keyword is in Solidity. So it's this way. This is not JavaScript required, I import modules. It just basically says require that the person calling this function, like I said, that value is a message sender. Require that message sender equals admin. Oh, JavaScript has ruined me. Now I can't tell whether it's 2 equals or 3 equals. I think it's 2. Require that message sender equals admin. If it's not, throw an error that says only admin can credit. This is an error message. Right? Let's say I also wanted to add another constraint that says the minimum credit amount is 50, for example. I would say require that amount is greater than or equal to 50. If it's not, throw an error that says minimum amount is 50. 50 what? I don't know, but 50. Then if these two pass, then we're going to update the balance of the receiver. Now we've used the require keyword to add 2 constraints, and we have used the constructor call to assign the contract deployer as the owner or the admin of this contract, and now we're going to see it play out here shortly. Good. So like we do all the time, we compile our contract and we deploy it. I'm just going to delete this guy so it doesn't clear all instances. Now, all this while, we're using one account to run transaction. And that's why this is the one that's depleted. It has 99 Ether left. We're going to keep deploying with that guy, make that guy admin. So essentially, when you select an account here, any operation you're doing on this tab will be done with that account, right? So if I deploy with the last account, for example, that has 100 Ether, and I call deploy, you see now it has 99.99. This guy has been used to deploy this. I actually want to show one more thing. I'm going to make this public and just to show an example of something real quick. I'm going to deploy this again. I think that it is set to auto compile. I think I'm going to deploy one more time, and I'm going to so now I can some nifty thing in Solidity is that if you make variables public, right, they actually become publicly callable functions, right? So if I call this view call on this admin, like I added public to admin here, right? Which makes it available to be called to get a value. And admin here essentially says the admin for this guy is the deployer. You can see the address here, 92148 is the guy that was used to deploy this contract, right? So nifty trick there. I don't have to write an admin function to get the admin or get admin. I can just assign public to that scope variable, and it will return the value. Cool. So I have deployed this now. Let's test our require calls and see if they're doing one. So I'm going to switch back to the first address we'll be using for a while now. Mind you, we didn't use this first account to deploy this contract, so it's technically not the owner. This DDC4. So we're going to use DDC4 to try and credit somebody's account. We're going to use DDC4 and we want to call credit. And we're going to, let's say this guy is a malicious player. He wants to just call credit on his account. So he calls credit and he wants to credit 400. What do we think is going to happen when we call this function? Now, when we call this function, we can see that this errored out. If you look at the details of this error, it says transaction to hello world credit errored, VM error revert. So any state change that happened before this execution was reverted, and the error says the transaction has been reverted to the initial state. Reason provided by the contract, only admin can credit. So this is us using our require keyword here to verify that only the admin can make this call. Now, by the time we switch back to the admin, to the owner of this contract, this account, right, this last one, which is 92148, and we call the same function again, we are going to have a successful call, and it's going to say credits worked successfully. And when we check this person's balance, it says get balance of this account, and we will get balance, we're going to get 400. So this credit was successful. The final thing we would like to check here is to see if we can credit somebody 20 units of our currency. And we're going to try this. We're calling this from the admin account, so we're expecting it to go through. But this will also revert. That says the transaction has been reverted to the initial state. Reason provided by the contract is that the minimum amount is 50. Let's check that. I think let's also verify that 50 is the minimum value. Let's try 50 and see if 50. Credit 50, 50 worked successfully. Get balance is 450 units of our newly created currency, and we are good to go. Ladies and gentlemen, that is a more than 1 hour intro to Solidity concept and ideas. Thank you very much. Does anybody have any questions? All right, back to chat, and I can see questions. All right, first there's a question in chat, and then Okon, you're going to go next. The first question is, does Solidity require a need to write tests using something similar to Jest or web oriented? Absolutely, yes. Testing is one of the most important parts of Web3 and Solidity development, because making mistakes in smart contract development are very, very expensive. Just like I said, because you cannot change code after you have deployed it, testing becomes all the more important. When we write tests for our web application, we are using it to test that they work, right? And sometimes when our tests don't catch issues, maybe our CI will catch it, maybe a customer will catch it, maybe we can roll back, fix a bug. But smart contracts, my friend, you mess something up, you get values wrong, or you get your logic wrong, or you don't test properly. It can be very disastrous. So yes, there are tools, lots of pretty mature tools for smart contract testing that are out there that we're going to explore over time. Cool. Who had their hands raised? I lost track. Okon Emmanuel, you can ask your question. You can unmute and ask your question. Okay. Okon Emmanuel says, I assume errored, yet treated as a just-in-case scenario. What are the ways to prevent this or handle something like this? Good. Good question. So like in software, we have to always think about edge cases, even when we're building web software. What if somebody sends -5 instead of sending a positive value, date and beautiful, like weird stuff like that. Just like with code that we write, we need to one make sure that we're processing data correctly, right? Checking data type, sanitizing, all of that stuff. But also, we also need to make sure that we have our design phase, we have our protocols designed properly, right? When you design something properly, you're less likely to make mistakes. Now, when you're designing as you write code, that can be a place for errors. Also, developers of smart contracts usually build in systems in place that can limit risk. Now, when I say limit risk, for example, you can hear something like when you hear maybe a smart token platform says they have paused withdrawals, that means that in their maybe due to a protocol glitch or a hack or something. That means that during their right. So imagine the code I just wrote now went somewhere here and wrote a function called pause that says once we have pause, nobody can credit, nobody can debit. Now that is a clause that they've added to the smart contract. Now, mind you, because smart contracts are technically always open source, people that are using your smart contract can see that you have this pause clause in your system. Now, this also means that you now have to also balance trust, because if you have so many clauses, or I call them backdoors, because essentially that's what they are. If you have clauses in your smart contract that allow you become a god, essentially that makes it possible for you to do and undo on your smart contract, you have reduced risk on your end to prevent these kinds of losses. But essentially, you have built a system that people cannot trust, because now it means that somebody has the keys to the system and they can SBF the system and maybe make away with people's funds. People don't want that, right? Yes, products, right? It's always a balance between security. All of these figure out how to balance them and make sure that they work the way they're supposed to work. For example, some people will come and tell you they will never use USDT because in the USDT smart contract, there's a blacklisting protocol where they can add an address to a blacklist, and that address can never spend money anymore, right? And that is something that USDT team did as part of maybe compliance with US governance rules, but that's something stability of like people developing these things. Did any like having smart contracts, some simple data types, how to move around data, and most importantly, how to compile, deploy, and execute functions on these smart contracts today. In our next session on contract, right? So smart contract can execute smart contracts. People can execute smart contracts. It's really like it's actually limitless the things that you can conceive and execute with these ideas and these patterns, right? So just like for example, like the example I gave before of betting, your friend bets on something, you create a smart contract, you put money in the smart contract. While building that smart contract, you can build a clause that says, if myself and my friend agree to transfer this money to another smart contract, this smart contract should transfer it to another smart contract. right? You build that into code. Let's say you create a function called agree to transfer, right? Where person A needs to say I agree, person B says I agree, and then the smart contract will transfer that. What essentially those people have done is that they've built in a fail-safe into their system that can say if the first smart contract has a bug, both of us can agree to move these funds away from the smart contract into a new smart contract and deprecate the old one and still be able to get the thing we created the smart contract for, right? So the answer to that is yes. But again, these things have to be done in a smart way. For example, if only person A had the ability to execute that function, it means they can scam the other person and just in the middle of the night just move the money out of the smart contract and send to themselves, and the essence of that smart contract has been defeated. Yeah. Okay, there are a couple more questions. Akara team, I don't know if we have the time to keep going with these questions, or we should, what do you recommend? But though, I think I would have a priority for people that want to voice out the questions. Shange, I hope I'm pronouncing your name correctly. If you want to unmute and ask your question, maybe we can take that question before.
Yes, you're pronouncing it correctly. Yeah, it's Shange. Um, yeah. Sorry, I followed along. I was coding along.
Okay, cool.
And I just hear for the contact, it's complaining of the constructed keyword or something. So I don't know. Is there maybe another?
Yeah, I can help you debug that. Like maybe if we after the last 2 minutes of the call when we've rounded up and closed, I could just help you debug one or two things and show you around.
All right.
Yeah.
Okay.
Cool.
Thank you.
I think that's pretty much it.
Thank you so much, Mr. Ibuka. Today's class was really valuable and very interactive. We don't even want to go. We don't even want to leave the call. We have a lot of questions, but we're not going to be taking any more questions after the ones we have because we've exceeded time limit, and I'm sure like we would want to stay and continue, but we just have to unfortunately round it up. So after these questions, I think it will be a fair time to end the class. So if you can just answer the ones we already have on ground, we would really appreciate that from you. Thank you very much. So there's one question saying generally more complex functions and contracts take more gas to execute. It's also up to the developer to write gas efficient codes. So over to you.
Yeah, so that was my answer to Ngo's question about if there are certain things that can escalate or reduce the fees. Yeah, Ngo, just about that. So essentially, when you look at the way we execute these functions, if you think of it as you're trying to use somebody else's computer to run your code and you're going to pay rent for it, right? So you pay them rent for the code that they're running. It's like paying Amazon on Google Cloud, right, to run your code in their cloud. Now, the longer or the heavier the process that you're running, the more you're going to pay in gas, right? So larger and more complex contracts and functions incur more gas cost. So this is something your developers think about when they're writing code. You cannot say loop over like a 50 value array and try to do everything on an array when there is maybe a more efficient algorithm to do that, because if you loop over 50 items, you're going to pay a lot of gas to execute that. So it's up to the developer to make sure they're writing code that uses gas efficiently and doesn't just do bad, expensive operations that cost people money. Yeah, Okon asked, is there a way to transfer funds from one smart contract? I think was that answered already? Yes, I think I answered that. We can transfer value from one smart contract to another, but the development life cycle for smart contracts is a lot of testing on testing networks or testing environments, testing VMs. So what people generally do is, for example, for the Ethereum virtual machine blockchain that we have, we can, there are also test networks that are out there, like free, where you can create yourself like 5 Ether and like deploy your contracts there and have them run for like days, weeks, or even months. Have your users beta test them on that network, verify it. Just like there's usually like a lot of testing that goes into these things up until the point where you feel like your smart contract is good enough to deploy to the main network and deploy it there. And also, yes, you can build a system of multiple smart contracts where you can have maybe logic in one smart contract, money locked in another smart contract. Just there's just a lot of patterns around these things as you develop more and more that are very unique to smart contract development. These are not problems you probably have in other like distributed systems, but because of this unique constraint of contracts being contracts that cannot change, there are a lot of patterns that come out of them. So the way I like to think about smart contracts is that a lot of times the code in smart contract are fairly simple. For example, like I said before, like the amount of USDT you have in your wallet now is just stored in an object in the USDT smart contract. That is it. Like there's no complex database and complex queries and ledger system that's built around it. It's a very simple, probably 10 lines of code that manages your balance and says what you can transfer and what you cannot transfer. But the complexity then comes from composing the smart contracts together and making sure that they stand the test of time without having to be rewritten and deprecated. Cool. Any more questions?
Thank you so much, Mr. Ibuka. Today was really good and very informative and interactive. We really appreciate your time and the value that you've given us today. As always, I'm not a developer, but I learned a lot from you today on smart contracts and Solidity. So thank you very much. And yeah, goodbye, everyone. We will meet on Friday for our next session. So thank you for coming and thank you for learning with us. Bye.
All right. Just good night.
Good night.
All right, bye everyone.